All right, so let's talk about what makes Python one of the most popular and, approachable programming languages out there. We're going to peel back the layers, and we're not starting with a line of code, but with a single, really powerful idea that shapes, well, everything.
This one sentence, this is the heart and soul of Python's design. But what does that actually mean? Well, it's all about clarity and simplicity. Instead of giving you 10 different confusing ways to solve a problem, Python tries to offer just one clear, straightforward path.
Okay, so that's a nice idea, right? But how does that translate into the actual nuts and bolts of writing code? Let's dive in and see how this philosophy directly shapes the language's most basic building blocks, leading to code that's just plain easier to write, read, and maintain. Let's start right at the beginning. I mean, the most fundamental concept in any programming language, how we store and label information. And right here in Python is where you get your very first taste of that simplicity. In a lot of other languages, you have to formally declare a variable and tell it what type of data it's going to hold before you can even use it. But Python, it lets you get straight to the point. It's what we call a dynamically typed language. And that's our first big clue about its focus on making things easy. You don't get bogged down in setup. You just start doing. And just look at this in action. You pick a name, you use an equal sign, and you give it a value. That's it. Seriously, there's no ceremony, no extra boilerplate code. Python just handles the rest, figuring out what kind of data you've given it. This is that obvious way we were talking about.
So whatever value you assign, that's what automatically determines the variable's type. Give it some text in quotes, boom, it's a string. A whole number, that's an integer. A number with a decimal, that's a float. You can even create more complex things like lists or dictionaries just as easily. Python just gets it.
So if variables are kind of like the nouns of our code, then we obviously need some grammar to organize them into coherent thoughts, right? And this is where Python makes its most famous and, for some people, its most controversial design choice. Now, this is probably the biggest thing you'll notice if you're coming from another language. While others use things like curly braces or special keywords to group code together, Python uses white space. Yeah, indentation. It's not just for making your code look pretty, it's meaningful. It is the syntax, which basically forces everyone to write clean, readable code from the get-go.
And it all follows the super simple, universal pattern you'll see everywhere. A statement that needs to control other lines of code, it ends in a colon. And that colon is like a signal, basically saying, hey, the next part is indented and it belongs to me. It's an incredibly consistent and really easy rule to learn.
And this focus on readability, it goes way beyond just the structure of the code. Let's see how it applies to one of the most common tasks in all of programming, mixing text with data. This is another spot where that one obvious way idea just really shines. So in the past, and honestly in a lot of other languages today, you'd have to use these weird placeholder symbols like %s for a string or %d for a number. Then you'd list all your variables at the very end. If you have a long sentence with a bunch of variables, it gets messy fast. You're constantly jumping back and forth to see what goes where. But now, look at this. This is an F string. You just pop an F at the beginning of your string, and then you can put your variables directly inside curly braces, right where they belong. It reads almost like a normal sentence. It's just so clean, so intuitive, so readable. And here's the best part. It's not just about looks. F-strings aren't just the most readable option, they're also more concise and they perform better than the older methods. They get turned into really efficient code behind the scenes, making them the clear winner. They are without a doubt the one obvious way to format strings in modern Python.
Okay, so we've got our variables, we've got our syntax. But what happens when our programs start to get bigger and more complex? How does Python keep all these names organized and stop them from, bumping into each other? This brings us to a really important idea called scope. You can think of scope as the rules that Python uses to figure out where to look for a variable when you use its name. And to keep this whole process simple and totally predictable, Python follows a consistent order of operations called the LGB rule. First, it starts with L for the local scope. That's right inside the function you're currently in. If it's not there, it checks E for the enclosing scope. This applies if you have functions nested inside other functions.
Next up is G for the global scope.
This is the main top level of your entire file.
And finally, if it still hasn't found it, it checks B for the built-in scope. These are all the names that come with Python right out of the box, like the print function. So this structured inside-out search, local, then enclosing, then global, then built-in, is the LEG rule. It's this simple, predictable order that keeps your code tidy and prevents all sorts of confusing bugs from naming conflicts. It's a really elegant system that just works in the background, keeping things organized for you. So, you see? From the way variables just spring into existence, to the readable, enforced structure of its code, all the way to the clear rules of scope, Python's design always points back to that one goal: clarity. It's all about finding that one obvious way to do things so you can spend less time fighting with the language and more time creating. The only question left is, what are you going to build?